So hey guys, welcome back to the channel. This is your Physics Buddy. So in today's session, we are going to discuss another important topic from mechanics in two dimensions, that is circular motion. We'll start the session with some previous year questions which were given in the last lecture, and we'll also talk about in detail what is circular motion and how different problems related to circular motion can be solved. This is going to be the last lecture of the unit, so stay tuned and make sure you subscribe to the channel. Alright, let's start from this question then. So it says that projectile can have same range for two angles, and we already studied that they can have same range for two complementary angles. Complementary angles means when the sum of these two angles are going to be 90 degree. So theta 1 plus theta 2 is going to be 90 degree. They're going to have the same range. So question says that T1 and T2 be the time of flight in two cases then. So what you can do here is you can assume 1 is supposed to be theta 1 and theta 2 can be taken as 90 minus theta 1 like that. So here we got angle for the second projectile in terms of the angle of the first projectile only. So what is the time of flight? Time of flight is going to be 2u sine theta by g. So I can assume that initially they have same velocity. So you can consider it as theta 1 and t2. I can consider it as 2u sine theta 2 by g. Now what can I write in place of theta 2? I can write sine 90 minus theta 1 by g. T1 is going to be 2u sine theta 1 by g. So if we just look at it, so T2 is going to be 2u cos theta 1 by g. Where T1 is nothing but 2u sine theta 1 by g. Now the question is saying we have to compare the range. So in order to do that, just multiply these two equations. So T1 times T2 is going to be 2u sine theta 1 cos theta 1 2u by g square. That is going to be 4u square cos theta sine theta by g square. What is the formula for the g? What is the formula for the range? It is u square sine 2 theta by g square. So ultimately it is going to be directly proportional. As you can see, it can write it as 2 u square cos theta sine theta by g square. So this is going to be r, and from this equation we can say T1 T2 is directly proportional to r, like that. So option B is going to be the correct one. Again, this is not an easy question. At the very first time, hardly you were able to do it, but you need to understand. As the question says, as the option says that the product of T1 and T2 is directly proportional to it. So just follow the process. So you have to find T1 and T2 first and then try to multiply it and then try to solve it. We'll ultimately get to the relation, that which is the required relation.
Okay.
This is how you are actually supposed to solve it. This question, did you try this one?
Yeah, I think I got it. So for the time of flight, I got 5 seconds.
Okay, and what about horizontal range?
Well, I got 212 meters.
Yeah, that's correct. What about this one?
You didn't assign that.
You didn't try it, right?
No, but you didn't. It was only those two you assigned for me.
Okay. So this is going to be your homework for today. You can try these questions else also. They are the same one. If you have done the previous one, you can easily do these questions as well. So if you just look at what we have done so far, so as of now, we are actually done with that unit as well. Let me just check it out. So as of now, we're done with unit 1, unit 2, unit 3, also unit 4. This is all about unit 4. So this is going to be the module 6 from unit 4 only. That too, motion in 2 dimension. And this is also referred as motion in plane. Now, as we have just completed the projectile motion, you can see that all the particles of the projectile will be moving equally along x as well as along y axis, like that. This way also it is possible, this way also it is possible. This is the case of horizontal projectile, whereas the second case is the case of ground to ground projectile. But that is not we have to learn in today's session. We have to talk about the circular motion. And whenever we are talking about circular motion, just try assuming this particular thing, that suppose there is a string and through that string I have tied up a stone. So what I'm trying to do is I'm just trying to fix that point, and I have given this stone a tangential velocity in this direction. So what will happen, as this stone is hinged, or you can say constrained to this point or the center of the circle, the stone will start reeling around this particular point in a circle, or you can say in a circular fashion. So the motion of this stone, which you can actually see here, that motion is supposed to known as circular motion. So here we can mention this particular point, that when any object constrained to a point in constrained to a point at a fixed distance at a fixed distance, then the motion possessed by the body referred as circular motion. That is what we need to keep in mind. Again, circular motion is two-dimensional motion. Particle must be moving in the two dimensions simultaneously, that is x and y. Sometimes it can be x and y, sometimes it can be yz, sometimes it can be zx. It depends upon in which case, in which direction we are actually reeling that object. Also, as it is constrained to the center, so the distance from the center to the point or the object is supposed to be the radius of the circle in which it is going to take place. Similarly, if we talk about the path of the path of the object, so it is going to be a circle. So as the path of the object is going to be a circle or circular, so the distance it is going to cover in one rotation is going to be the circumference of that circle. And the circumference of circle, we already know it is given by 2 pi r, where r is supposed to be the distance. It is supposed to be the distance from the center. And we can also call it as radius. But don't call it as radius, because sometimes circular motion which an object is performing is not actually moving in a circular path. But at a point, it might be taking a turn, and the turn will ultimately give us some distance from the point where it is supposed to be going on. So there are few things that we actually try to calculate here. The first thing is, what is the time period of revolution? So time period of revolution is simply given by distance over speed. So as the distance is going to be 2 pi r, that is circumference, speed is going to be tangential velocity. So time period is going to be 2 pi r by t. This is the time period for one rotation. As well as for so many other rotations, we can calculate the same. Again, it is going to be distance, not displacement. Keep this in mind. Also, apart from this, circular motion can also be categorized into different types of motion. Like, let me give an example. If I'm talking about circular motion, it can be of two types. First, it can be uniform. Second, it can be non-uniform. Uniform circular motion is something in which the speed of the body or the object which is rotating is fixed, in which speed is constant. Whereas in non-uniform circular motion, speed is not constant, it is variable. But in both the cases, we just try to understand this fact. Speed is something which can also be referred as magnitude of velocity, whereas magnitude of velocity is going to be constant. Whereas in non-uniform circular motion, magnitude of velocity is also changing, so it is not going to be constant. So here, what you can understand from this particular part, that if the speed of the particle is increasing, like it can be increasing at a uniform rate, it can be increasing at a uniform or non-uniform rate. Just try to understand it with an example of the fan. When we turn on the fan, the wings of the fan were not initially moving with its maximum speed. Initially, it started with zero speed, then it constantly increases. So here, the speed is variable, or you can say the magnitude of velocity is not constant. It just keeps on increasing. But if we just look at the other part of rotation of Earth, revolution of Earth around Sun, revolution of any other planet around Sun. So in that case, that motion is sometimes which is referred as uniform circular motion, because speed is constant, or you can say the magnitude of velocity is constant. So in our curricula or at this particular grade, speed is always going to be constant. We are never going to see variable speed case, because non-uniform circular motion is the most difficult one. Like, this is the most difficult two-dimensional motion which we ever studied. So here also, we're not going into that. Let us talk a few more things about uniform circular motion. So uniform circular motion, as I mentioned, these things, that the first characteristic of this is speed of
body is going to be constant. And the speed of body is going to be constant means magnitude of velocity is going to be constant. But velocity is not going to be constant because if you just look at the motion of the particle, at every point, the direction of velocity is changing, right? So the direction of velocity is changing at every point. And we know if you're talking about velocity, velocity is a vector quantity. And in vector quantity, if direction is changing, then means the whole vector is changing. What is constant here? Magnitude of velocity is constant. But velocity is not constant. This is again, you need to remember. Velocity is not constant here once again. So if velocity is not constant, what we can infer from this? We can infer from this is that in kinematics, we have studied this one fact that if velocity is changing, it means the body must possess acceleration. This is the important part from this particular topic. As we know that velocity is not constant, it is changing, but it is changing due to what? It is changing due to its direction. So there must be some acceleration which is produced due to change in direction of the body, or direction of velocity. So this acceleration which is produced due to change in direction of velocity of the object, this acceleration is called centripetal acceleration. Now, let us go a little more deep into it. So velocity has two things. One, it is going to be magnitude. Another, it is going to have direction. In kinematics, we just studied that the rate of change of velocity is acceleration. This means if anyhow we are able to produce a change in velocity, we are able to see some acceleration. So what are the ways of changing, or what are the ways of producing change in velocity? Either by changing its magnitude, either by changing its direction. So in uniform circular motion, magnitude of velocity is constant. It is not changing. Magnitude of v is constant. It is not changing. So acceleration is not going to be produced due to this magnitude change in velocity, but direction is keeps on changing. So the direction keeps on changing, then the acceleration we are going to see here, this acceleration is known as centripetal acceleration. The centripetal acceleration is the acceleration which is always directed towards the center of the circle. And the centripetal acceleration is a cause of changing direction of velocity. The centripetal acceleration, when we found that the centripetal acceleration is equals to v square over r. So this is one such relation we have to keep in mind. And as we're talking about uniform circular motion or any type of circular motion, body always possesses centripetal acceleration. And the magnitude of centripetal acceleration is nothing but v square by r. What should I do?
Mm.
So whatever type of circular motion we are having, body will always possess centripetal acceleration.
Okay.
Let me just give you a few glimpses of non-uniform circular motion as well. So we are talking about non-uniform circular motion. The most clear part here is velocity is going to be non-uniform. Velocity is going to be non-uniform, or it is not constant. That's it. It is not going to be constant. So if it is not going to be constant again, there must be few changes that are taking place in this velocity. One, there might be some changes in the magnitude of the velocity, or there might be some changes in the direction of the velocity as well. So if there is a change in the magnitude of velocity, we can say its speed must be variable. And this variable speed leads to another type of acceleration, which is called tangential acceleration. And this tangential acceleration is represented by AT, and this AT is equals to r times alpha, where this alpha is angular acceleration. Although it is not in your syllabus, so I'm not going into details of it. Just giving you an idea that if there is a non-uniform circular motion, object must be moving with non-uniform velocity, and that non-uniform velocity results in changing in its magnitude as well as in direction. So changing magnitude will leads to tangential acceleration, Whereas change in direction, as we already discussed, it leads to centripetal acceleration. So now there is one question for you. Which acceleration must be there for a body possessing circular motion?
Mm,
We have two types of circular motions. It can be uniform, it can be non-uniform. Which type of acceleration must be possessed by a body if it is undergoing circular motion? That is the question. Think and ask. Think and tell.
mm. Is it centripetal?
Yeah, it is going to be centripetal only.
Because the change in what's it called?
Because the changing direction of velocity will always be there.
Right.
Till the time it is going on in circular motion, there must be changing direction of velocity. And if there is changing direction of velocity, there must be centripetal acceleration. And that centripetal acceleration is always equals to velocity square by r.
Mhm.
Whereas if the magnitude and velocity also changing, like it is increasing or decreasing, just like the fan, when we just turn on the fan, its speed increases. When we just turn it off, its speed slowly decreases and becomes zero. So during the time of increase and decrease of speed of fan, particle or the fan wings will also possess tangential acceleration. Whereas throughout the motion, centripetal acceleration will always be there. So again, this is something which just need to keep in your mind. Nothing serious about it.
Okay.
Next. So we talked about Newton's second law of motion. Do you remember it?
Mm. I think that's
What was Newton's second law of motion? Think and tell me.
Oh, what's the acceleration is like proportional to net force.
What?
Like the acceleration of an object is proportional to its net force. I mean, to the net force like acting on it.
That was the result, or you can say the mathematical result when we assume that mass is constant. That is not something you need to learn. The law says that the rate of change of linear momentum of an object is directly proportional to the external force applied. This is what the second law of motion says. So here, if we just try to solve it mathematically, we'll say that it is going to be dp by dt. Now, as this honors physics doesn't involve calculus, so let me just not introduce that thing. So you can just write it out. It is going to be change in momentum. So in place of dp, I should write delta p by t, like that. So delta p can be written as final minus initial momentum. So final momentum is going to be mv, initial momentum is going to be mu over t. Now, we can take mass common from this particular equation. So inside the left with v minus u by t. If it is constant, then only it is going to happen. So as mass is going to be constant, also this proportionality constant k is going to be 1. So force is supposed to be m v minus u by t. Now, from first equation of motion, what is the first equation of motion? The first equation of motion says v minus u is nothing but a times t. So v minus u by t is going to be a, right? In place of this, we can write force is going to be mass times acceleration. Now, this is something which we have already discussed. But the thing is, if we just try to understand same thing by looking at uniform circular motion, we can see here that there is some acceleration, this is called centripetal acceleration, which is due to the change in direction of velocity is there in circular motion. So if this acceleration is there, and obviously whenever we are going to talk about the mass of any object, or if any object is revolving in a circle, it must possess some mass. So I can say here that if a mass is moving in a circular motion, it must have centripetal acceleration. And if it has centripetal acceleration, I can say it must experience a force, and that force here is called centripetal force. So what is centripetal force? That is the next question. So centripetal force is something which is represented by Fc. It is going to be the product of mass times centripetal acceleration, which is going to be mv square by r, where r is what? R is the radius of the circle. Now, what exactly centripetal force is? Let us try to define it. So centripetal force is basically a force which acts in a circular motion always towards the center. It is kind of force which always acts towards the center whenever a body is acting or moving in a circular path in a circular motion. And that is something we call centripetal force, and this is equals to mv square by r. Now, to just understand everything once again, suppose there is a body and it is going in a circular path revolving in performing a circular motion. So what are the things that it may possess? First of all, it must have a tangential velocity. Due to this tangential velocity, or you can say as the body is constrained with some center r, so at every point, the tangential velocity must be making 90-degree angle with this r. This is the first point we can infer from this. At every point, tangential velocity must be making 90 degrees with radius. Whatever circular motion it is, this thing must be there, 90-degree angle between radius and tangential velocity. Second point, in every type of circular motion, which acceleration we always observe? Tell me.
Mm,
In every type of circular motion, which type of acceleration we always observe?
centripetal.
Yeah, so in every type of circular motion, centripetal acceleration will always be there, as it is due to change in direction of velocity of object. And it is always directed towards the center. So this is its direction. And again, this is also important. What is the direction of centripetal acceleration? It is always directed towards the center. So we can represent here centripetal acceleration must be directed towards the center like that. Next point. The force which acts towards the center is called centripetal force, which is equals to mv square by r. Also, centripetal acceleration is going to be v square by r. And the direction of this force is directed towards the center once again. Remember this thing. So here I can say that here must be some force, that is centripetal force, which is acting towards the center. So this is all about the circular motion that you need to understand as per the requirement of this curriculum.
Mm.
How all these things are changing, why there is this particular acceleration. Although this is not only limited to it, there is like a lot more extension. There is a whole non-uniform circular motion as well as few other things are also there. But as per the requirement, this is it. So once I share these notes as well as the question for the homework, just make sure you try them out. Let's do some questions based upon this particular topic only, and then we are good to go with this particular topic. So a very simple question I'm starting with. A stone of 100-gram mass is reeled in a circular motion of radius 2 meters at any point of time its velocity is 5 meters per second. Question is find FC, find centripetal force. Try it out, you can do it.
Okay. For number one, I got 1,250 newtons, I guess. How
What
do
you
you
got once
express?
again?
Huh?
What you got? Tell me once again.
1,250.
First of all, whenever we are solving any problem, make sure you take everything in SI units. You have to convert the mass of the stone from grams to kg. Then only the answer will be relevant.
Right.
So convert that and do that conversion and then tell me.
Okay. $1.25.
All right.
What
Try the
would
second
be
one.
like? How do you express in units? Like newtons?
Yeah, force is always in newtons.
Okay.
Try the second one.
Okay. I got 64 meters per second squared.
Tell me once again.
64 meters per second squared.
Let's see.
Oh, it's radius of
Okay.
25 centimeters. I didn't convert that.
Yeah, radius is 25 centimeters. You have to convert it in meters. So V is 40, so it is going to be 40 times 40. It is going to be 25 into 10 to the power 2. That is 100. So we'll have 6,400 meters per second square. That is going to be the centripetal acceleration.
Mhm.
So just remember the conversion. Conversion is important. You have to convert every time whenever we are solving
Right.
this particular thing.
Okay.
What was the lesson 3?
Lesson 3. What do you mean?
Yeah. This is lesson 2 from module 6. What is the lesson 3 of module 6?
Um, Relative velocity.
Okay. We'll do this. We'll do that part once that is being discussed in the class. Because again, relative velocity is a huge one. Like it can be done in 1 dimension. It can be discussed in 2 dimensions.
Okay.
It has whole lot thing. So we'll do it once it is being discussed in the class. Then only we'll do that. From the next class, we'll move to the different parts. All right. So let's just do a practical question. So question says, find centripetal force experienced by Earth while revolving around Sun at a distance of 10 to the power 15 meters. Now, this is a little tricky one. You have to think so many things in order to solve this problem. Try this out and tell me.
All right. So we have to think of the circle as, so there's a circle and the center point would be the sun, and then
Mm.
the object going around is the Earth. But how would you know the velocity? Since we need the velocity for the
How
quantum,
much time Earth take to complete one revolution around Sun?
24 hours,
Think again.
12 hours,
How much time Earth take to do one revolution around Sun?
is it not 24 hours?
1 year, 365 days.
Oh, around the sun. Yeah, 1 year.
Not on its own axis. I'm talking about around the Sun.
Oh, okay.
So we know the time period. We know the radius. We can find out the velocity. We can find out the velocity of Earth. It should be 10 to the power 15 meters, not 5.
Okay.
The time it took is 365 days. Again, these 365 days need to be converted into seconds. So one day has 24 hours, 1 hour has 60 minutes, 1 minute has 60 seconds. Now this will give me the time in seconds. And what about the distance? Distance is going to be 2 pi r because I'm assuming that the orbit is circular.
Okay.
So 2 into 3.4 into radius, that is 10 to the power 15 meters. Now you can find out the velocity, 2 pi r by t. Find it out and tell me what is the velocity of Earth. I'll be back in a minute.
Okay.
So what's the velocity?
We got 1.49.
1.49 times what?
Times. Oh, right. There's the e to the power of 18.
Meters per second, right?
Okay.
Now again, we can find out the centripetal force now. Fc is going to be mv square by r. So you can also do that. You can write 2 pi r into 2 pi r by r. And this t square as well. So this will make it a little complicated. Just substitute the values as it is. So 6 into 10 to the power 24 times 1.49 into 10 to the power 18 square divided by the time, which you have just figured it out. So you can solve it and you'll have the complete answer. So the force which Earth experiences, which is acting towards the center, is huge. And this force is actually because of the gravitational force, that is the attraction between the sun and the Earth. Find out the complete value. So something like that will definitely be there, like a problem related to Earth and Sun.
Yeah, it
Something
was
like
there.
that will be. So we
Yeah,
just need to
actually,
have. So what was the topic that you learned in the class, in the last class in the school?
it was a graphic motion.
Isn't it done yet?
Yeah, it's done. We had the test, but no, I'm saying that's the last topic we learned because the last thing we did in class was have the test. We didn't start anything new.
So you didn't go to the school on Friday?
No, I said we had holidays on Thursday, Friday.
On what occasion?
Yeah, I think it was just like fall break or something.
Fog break.
Fall break, yeah.
You're
Like
saying
fall,
fog.
the season, fall, autumn.
Okay.
Yeah.
The 2 days break. Yeah, that's interesting.
Mm.
So what you
No,
got?
we have an actual Thanksgiving break later, but they just wanted to have another break, I guess.
Yeah, that's pretty fine. So what do you got?
I
FC.
got 2.12 times 10 to the power 45, or e to the power. Does e and 10 are the same thing?
What is same thing?
I got, so it's 2.12 times e to the power 45. Does e just mean 10?
No, E is different and 10 is different. E has different value. Its value is 2 point something like that. Its value is different. It's not the same. So we cannot use E. We have to use 10.
Okay. I mean, it's outputting the answer in e.
Yeah, but you should not do that.
Okay, so it was 2.2 though. 2.12.
10 to the power 40, you
45.
say.
Yeah, 40.
That much force exists between Earth and Sun, and Earth is revolving around the Sun.
Mhm.
All right, then let's keep it till here only.